Hi students, here is the class for you on the topic types of organic reactions. From the chapter Organic Chemistry, some basic principles and techniques. Dear students, here I have written the mind mapping for you. All the organic reactions can be broadly classified into these categories. Here 10 categories I have written here. Let's see one by one briefly. Here is the first one, substitution reactions. In the organic reactions, the first type is substitution reactions. In this reaction is that of which involves direct replacement nothing but displacement or substitution of an atom or a group of atoms in an organic molecule by another atom or another group of atoms without any change in the remaining part of the molecule. That could be done in these substitution reactions. Okay, now let's see about addition reactions. In these two, substitution and addition reactions also, there are three categories. First one is nucleophilic type, and second one is electrophilic type, and third one is free radical. So this is known as nucleophilic substitution reaction and electrophilic. Here let's see, in these substitution reactions, for suppose the substitution reaction which are brought about nucleophiles. So which are brought about nucleophiles are called nucleophilic substitution reactions. Okay, in all these reactions a stronger nucleophile is usually displaces a weaker nucleophile. Just I am giving the brief introduction, just like definitions only. I'll give you a clear-cut idea about all of these 10 types of organic reactions in this session. Right, in this electrophilic substitution reaction, which are brought about by electrophiles, are called electrophilic substitution reactions. Nothing but substitution reactions which are brought about by electrophiles. So here is the free radical reactions. Substitution reactions brought about by free radicals, that is only known as free radical reactions. Like that only addition reactions also, three types. The reactions which involves combination between two reacting molecules to give a single molecule of the product are called addition reactions. Okay, for suppose if it is a nucleophilic addition reaction, these addition reactions brought about by nucleophiles, that is known as nucleophilic addition reaction. And for suppose it is electrophilic addition reaction, the addition reactions brought about by electrophiles are called electrophilic addition reactions. For suppose if it is free radical addition reactions means the reactions brought about by free radicals are called as free radical addition reactions. Right, and third type here we have elimination reactions. Elimination reactions nothing but an elimination reaction is one of that involves the loss of two atoms or groups, nothing but group of atoms from the same or adjacent atoms of a substance, leading to the formation of a multiple bond. Multiple bond you know very well, either it is a double bond or triple bond. These two are the multiple bonds. Here we have that alpha, beta and gamma elimination types. Okay, depending upon the relative position of the atoms or groups eliminated, these reactions are classified as alpha elimination and beta elimination and gamma elimination. For example, base catalyzed, nothing but dehydrohalogenation of chloroform. So these are the examples I'll discuss with you later, and this is about elimination reactions. And next one what we have here, rearrangement reactions. Reactions involving the migration of atom. Here is the important one, the migration of atoms. Migration of atoms or group of atoms from one atom to another within the same molecule is known as rearrangement reactions. Okay, now let's see the definition of condensation reaction number 5, fifth type. Okay, in these condensation reactions, two or more molecules of the same or different reactants combine to form a product with or without the elimination of simple molecules. Without the elimination of simple molecules such as here just H2O and HCl, NH3, like these simple molecules elimination just ROH. Okay, let's see briefly about these. And number 6, what we have here, isomerization reaction. In these type of reactions which involve interconversion of, here you can see, interconversion of one isomer into another. Interconversion of one isomer into another, keeping the molecular formula as well as the carbon skeleton of the reactants and the products. Okay, let's see briefly. This is the definition. And next one, what we have here, pericyclic reactions. There are large number of organic reactions which do not involve ionic or free radical intermediates. That's about pericyclic reactions. And number 8, what we have, polymerization reactions. These reactions involve the union of, here I am going to write, the union of large number of small molecules, just like monomers. Here you have to see the involvement of monomers to form a molecule with high molecular weight, nothing but polymer. So this polymer having high molecular weight. Here these are the monomers which are having very small amount of molecules. These are called as monomers. From these monomers, how the formation of polymers we have to study in this polymerization reaction. Let's see about next one here, what I have written, combustion reactions. So students, you know very well, combustion reactions nothing but heating reactions. In these reactions, in the presence of oxygen only, in the presence of O2, the substance is going to get fire. So it is presence of oxygen, so it is known as oxidation reactions. You know very well, the addition of oxygen to any other substance is known as oxidation reactions. Okay, these are oxidation reactions. About these combustion reactions also we are going to study in these types of organic reactions. Okay, in these types of some examples also I am going to explain to you. Next special category of these oxidation reactions. And students, here one new point you came to know, the last type, oxidation reactions. It is just combustion is generally oxidation reaction. This is combustion also oxidation reaction, as I told you. And students, all the oxidation reactions are not combustion reactions. Okay, these oxidation reactions may be carried out using some oxidizing agents. Oxidizing agents. And these oxidizing agents are nothing but oxidants, are the substances that oxidize the other substance. Okay, about this also we are going to study in this session of the topic, some types of organic reactions, chemical reactions. Okay, now students, in this session I am going to explain to you just briefly about the last one, combustion reaction and oxidation, including these two for substitution and addition and elimination, rearrangement also. Okay, basing upon the time, okay, I am going to explain to you. Let's get into the class. This is about the complete mind mapping and what is the introduction part of this today's session. This combustion reaction, it's a burning process, as I told you, and most probably carbon. In your 10th standard in CBSE and state also, we had studied about these carbon and its compounds. In this, the combustion reaction briefly was there. That was, just we can recall what we had learnt in our previous class. And carbon and its compounds burn in the presence of O2 or air to give, that means to produce CO2 and some light also. This is the basic principle. Okay, this process of burning of carbon or carbon compounds in excess of oxygen to give heat and light is called combustion reaction. The main definition of that, in the reactions, carbon and its maximum oxidation state of +4 in the product. Okay, for example, just I'm going to write C plus O2. Nothing but the product is CO2 plus some energy, that's light energy. And for suppose C2H6, the molecule, if you take if you heat this compound in the presence of oxygen, it is a combustion reaction, so there is a need of oxygen. So it is the molecule of ethane. Okay, C, carbons are 2 and root word is eth. So here what are the products? Carbon dioxide must be there, and including with that H2O also. Okay, now students, let's balance this equation. How many carbon atoms are there? Both sides you need to balance them. If you keep in front of this 2 and here 4, so carbons balanced, and now in front of this oxygen, if you keep here 7 and here 6. Now if you count these number of atoms, both sides, in the reactant side and the product side, both are equal here, plus energy. And here let's see the third example, CH3 CH2 OH. OH is the alcoholic group. Okay, this is ethyl alcohol. The combustion process of this ethyl alcohol, again the products are same, CO2 plus H2O plus energy. Okay, now students, let's balance this equation. Here 3O2 and 3H2O. Now if you count all the atoms presented in these both sides, it should be balanced, ethyl alcohol. Okay, generally saturated hydrocarbons burnt with a clear light blue flame. Saturated hydrocarbons, you know that, as I told you previously, saturated hydrocarbons nothing but alkanes. Alkanes only, the saturated hydrocarbons. Okay, burn with a clear blue light flame, whereas unsaturated hydrocarbons nothing but alkenes and alkynes, both are unsaturated. Okay, unsaturated. They should give the flame of yellow colored flame. So by observing the flame color, you have to identify whether they are saturated compounds or unsaturated hydrocarbons. Also you need to identify basing upon this flame observation. Okay, here is the yellow colored flame with soot. Soot nothing but some smoke. So some smoke you have to observe in that flame. For suppose if air is not sufficiently available during this combustion, even saturated hydrocarbons give sooty flame. 1. Coal and petroleum, etc. These are the examples. Okay students, this is about combustion reactions, and these are the examples of combustion reactions. Next we shall go for oxidation reactions. In this oxidation reactions, one very important point and confusing point you have to know. Dear students, here you can see combustion reactions are oxidation reactions. As I told you, here in the examples also you can see all of these combustion reactions, there must be a presence of oxygen. So here is the oxygen, here and here also. So the addition of these oxygens into any other substances, these are called as oxidation reactions. So here see the sentence, all the combustion reactions are oxidation reactions. So this is correct. And here is the new point, but all the oxidation reactions are not combustion reactions. Why? Because all the oxidation reactions, if you add any oxygen to any other substance, that must not a combustion reaction. So there is no possibility of that reaction is a combustion reaction. So this point also correct. So we have to remember all of these two sentences also. Okay, and these oxidation reactions may be carried out just by using oxidizing agents, nothing but oxidants. Oxidizing agent, it's also called as oxidant. Okay, oxidizing agents are these oxidants, which substances that oxidize the other substance. These oxidizes other substance. these oxidants are oxidizes the other substance. So now you can say they themselves undergo reduction. So these are helping to oxidize the other substance, then themselves they undergoes reduction process. Why? Because from the substance oxygen is removed from the substance, so that must be a reduction. Okay, now let's see the example of these oxidation reactions. What we have here, students, a compound of CH3 CH2 OH. Here is the alcoholic group OH, so the name of this compound is ethanol. Here OL is the suffix. Ethanol, this is also called as ethyl alcohol, right? And here alkaline potassium permanganate KMnO4, alkaline potassium permanganate or acidified potassium dichromate. Acidified K2Cr2O7 is the potassium dichromate. In solutions act as oxidizing agents. These two. Then supplies oxygen to the converting alcohols into carboxylic acids. Now let's see the product. What should be formed here? CH3 CHO. So CHO is the aldehyde group here. Then the name of this compound is ethanol. Here Al is the suffix. This is also called as acetaldehyde. Okay, from this the final compound is CH3COOH. This is known as ethanoic acid or acetic acid. Okay, this is the example. And here ethyl alcohol undergoes, this is the ethyl alcohol undergoes oxidation to form the product of acetaldehyde and finally the acetic acid. Okay, here these two KMnO4 and acidified potassium dichromate K2Cr2O7, these two are acting as oxidants, nothing but oxidizing agents. So these two are helping, that means these two are producing these oxygen to this ethanol, then it get oxidized. Okay students, this is about oxidation reactions. Coming to our mind map, what I have written in the starting, this is oxidation reaction, so it is completed. Now let's see the first one. Here is the first one, substitution reactions. In this again types, okay, let's start now. Substitution reactions, and these types nucleophilic, electrophilic and free radical substitution reactions. The first type is substitution reactions. Let's see the definition of this. A reaction in which an atom or a group of atoms in a given compound, it can be replaced by other atom or a group of atoms is called as substitution reactions. For suppose alkanes, the saturated hydrocarbons, these are chemically least reactive. Therefore, they are also called paraffins. Okay, why? Because param means a little and affins means affinity, that is no affinity towards the chemical changes. However, they undergo some chemical changes under suitable conditions, which are substitution reactions. For example, methane is the example, best example here, reacts with chlorine. Here students, CH4 is the methane formula, plus if you add chlorine, Cl2, and in the presence of sunlight, what should be formed here? CH3Cl with HCl. Here the name of this compound CH3Cl is methyl chloride, and the name of this compound you know very well, hydrochloric acid, and here is the methane. Okay, right. And now This formed methyl chloride. Methyl chloride, the formula is CH3Cl. Again it is treating with chlorine. Okay, and here this is also in the presence of sunlight, so I'm no need to just I'm not writing here. Then the formed compound is CH2Cl2 with HCl. Here the name of HCl, you know, hydrogen chloride, nothing but hydrochloric acid, and here is the compound CH2Cl2 is methylene chloride. To this methylene chloride, again if you add chlorine, this methylene chloride formula CH2Cl2, to this if you add again chlorine in the presence of sunlight, the compound, the formed compound is CHCl3 including with HCl. Okay, this formed compound CHCl3, the name of this compound is chloroform. So now students, again to this chloroform, if you add chlorine, CHCl3 is the molecular formula of chloroform to this chlorine. Now the reaction takes place in between these two in the presence of sunlight. Then the formed compound is carbon tetrachloride including with HCl. Okay, this is only carbon tetrachloride. Okay students, this is about substitution reactions, what you had studied in your 10th standard, carbon and its compounds. Now let's see in the first type, nucleophilic substitution reactions. The substitution reactions which are brought about by nucleophile. Nucleophile is called nucleophilic substitution reactions. And in all these reactions, a stronger nucleophile usually displaces a weaker nucleophile. You have to remember this. A stronger nucleophile replaces a weaker nucleophile. These reactions are typically just typical of alkyl halides. Very tough in alkyl halides. For example, hydrolysis reaction of an alkyl halide with an aqueous base. You can see here I am going to write OH minus plus, if you add any alkyl halide to this, RX. Okay, and here is the delta plus and delta minus. Here this OH minus is hydroxide ion and here it is acting as stronger nucleophile, and RX is alkyl halide here which has positive and negative charges. And students, here you can see stronger electrophiles are replaces the weaker electrophiles. Here the formed products, let's see now. ROH plus X minus. Instead of this X, you can take the halides. X is equal to chlorine, bromine and iodine. Okay, and here is this name of this X minus is halide ion. Okay, this is only weaker electrophile. Here ROH, the name of this ROH is alcohol. So substitution product, this is the substitution product. Then the final product is halide. So here is the weaker electrophile and here is the stronger electrophile. So this is the example of nucleophilic substitution reactions. Now let's see about the electrophilic substitution reactions. The definition of these electrophilic substitution reactions: these reactions which are brought about by electrophiles. These are called electrophilic substitution reactions, and these reactions are typical of arenes and other aromatic compounds also. For example, halogenation of, and the next one is nitration, sulfonation and Friedel-Crafts reactions. Now let's see the example of these electrophilic substitution reactions. Here is the benzene. We have to see the structure of benzene here, plus Cl plus here Cl2 plus FeCl3. So this is chloronium ion. Chloronium ion. This is acting as electrophile here. Electrophile. This is the reaction. Chlorination. Okay, students. Chlorination. Why? Because the addition of chlorine is taking place here. Then the final products should be, I'm going to draw here. Here is the benzene structure, and here chlorine is attached with H plus ions. Here is the H plus ions. So the formed compound is known as chlorobenzene. This is chlorobenzene. So this is known as substitution product, chlorobenzene. Okay, right. Now let's see the another example. Here is the benzene. Again we have to take plus. If you add NO2 plus, here it is acting as electrophile. This is known as nitronium ion, and here HNO3 plus H2SO4. In the presence of these two acids, this is called as nitration. Acting as an electrophile, and it is nitronium ion. So this is the process of nitration. Then the formed products are, here is the NO2 attacking NO2 group to this benzene plus H plus ions. So the formed product is known as nitrobenzene. This is the substitution of substitution product in this electrophilic substitution reactions. So students, this is about electrophilic substitution reactions, and these are the examples to this to this benzene. If you add chlorine, and if you add nitro group also, chlorination process and nitration process we have studied in this electrophilic substitution reactions. Now let's see about free radical substitution reactions. Free radical substitution. Here these substitution reactions brought about by only free radicals. The example of these free radical substitution reactions, the first one is chlorination of methane. Here students, methane, CH4 methane, and if you add chlorine to this, and methyl chloride should be formed. Here at particular temperature 520 to 670 Kelvin you have to maintain, or in the presence of sunlight also. Okay, and methyl chloride should be formed. This complete reaction occurs by free radical mechanism, which involves the steps of, the first one is initiation and second one is propagation. Let's see about that. What is initiation and what is propagation? In this first step, homolytic fission could be done. This is the chlorine molecule, Cl and Cl, these are the chlorine atoms, and homolytic fission. Okay, then students, free radicals should be formed of chlorine. So 2Cl chlorine free radicals are formed here. Here you have to maintain 520 to 670 Kelvin temperature, or else if you place it in a sunlight also, the reaction could be done. Next, second one, you have to see the propagation. This propagation could be done in two steps. In the first step, methyl free radical has been formed. This is methyl free radical. Okay, from the shifting of this single electron towards this hydrogen, and here this bond should be like this. So methyl free radical. After that, in the second step, this CH3 methyl free radical, if you add chlorine Cl chlorine molecule to this, then the formed compounds are CH3Cl plus chlorine free radical. Okay, and here this single electron transfers towards like this, and this bond like this. Now this is the second step, and the third one is, here is the second one, propagation. Now the third one is termination. In this termination, chlorine free radical, and here is the chlorine another free radical, these two combining together, then chlorine molecule should be formed. Here is the methyl free radical, and it is combining with another methyl free radical, then CH3 compound should be formed. This is also called as C2H6. Okay students, this is about the substitution reactions, 3 types. In this free radicals, initiation, propagation and termination also we have studied. And students, in these substitution reactions, the first one, electrophilic substitution, and in this some examples also I have explained to you, and nucleophilic substitution reactions also I have explained to you, and free radical substitution also completed. Okay students, let us conclude this today's session. In this, what just we have to recall what we have learned. Let's see the mind map once. About combustion reactions I have explained, and oxidation reactions, and only substitution reactions, these 3 types completed. Okay students, in this session, if you understand the topic, you can convey your doubts and your views also in the comment section. I'll be starting with these next one, addition reactions, elimination and rearrangement, and all of these in our next class. Okay students, thank you for watching. Thank you so much. Have a nice day.